CVExplorer, a novel interactive system for visualizing cybersecurity threats from databases of known vulnerabilities. One such database is the National Vulnerability Database. It is a U.S. government repository for vulnerability management. NVD provides CVSS scores for almost all known vulnerabilities. CVSS is a free and open industry standard for assessing the severity of vulnerabilities. NVD uses common vulnerabilities and exposures to store its known vulnerabilities. CVE contains information and at least one public reference for publicly known cybersecurity vulnerabilities. NVD also provides some basic visualization about the vulnerabilities stored, such as distribution by vulnerability type over time, relative vulnerability type, totals by year. CVE details also provide some basic visualization for the known CVEs, such as the list of vendors and products, and the current CVSS score distributions. The previously mentioned visualizations are mostly looking at the individual single-dimensional view of the CVEs. Our proposed solution, CVExplorer, provides multi-dimensional visualizations of the CVEs with different link views. We adopted parallel coordinate to present the relationships of the prominent dimensions in the CVEs. We also used time orders, which was implemented using orders and stream graph algorithms, so it has the ability to give the quick emphasis on important terms and the evolution of the underlying topics over time. A network with force-directed layers is used to group related entities. The entities are considered as related if they appear in the same CVE. Interactive features are also added, and these views are interconnected to support analysis at different levels of detail. For instance, users can reorder the dimensions of the parallel coordinates to see different correlations. Users can browse the view based on the sample CVEs. Users can also search for terms in the CVEs. Users can focus on some severity rankings by disabling the other. Users can focus on some dimensions in the CVEs by disabling the others. User can click on a term to see its distribution over time. Users can click on an individual term to further investigate the CVEs related to it. On the network view, users can adjust the link counts in order to focus on terms with larger or smaller link counts. Use case number 1. CVE 2018 dataset was collected from NVD feeds page in July 2018 and fed into our system to analyze in this use case. Its severity distribution is shown here. We can focus on the critical CVEs by disabling the others. We will focus on the relationship between vendors and problem types by disabling the products. CWE89 is highlighted as a dominant problem type in this dataset. Clicking on it to see its distribution over time. Clicking on it to see the CVEs related to it. Examining one related reference to find information about that. We can see that this problem type is related to several command and SQL injections. At the network view, we can filter the link count. See that CWE89 is here. Our visualization can be used to analyze any set of CVE dataset. For instance, we extracted a set of CVEs for a specific ASN from Soden.io and analyzed it in this use case number 2. Soden is one of the first search engines designed to crawl the internet and to index and discover services. Users can obtain vulnerability information for a specific host. User can click on View Raw Data to view a long list of relevant CVEs. The severity rankings of the CVEs are distributed as shown here. Time orders highlights the critical problem type, vendor, and products in the past as CWE199, Microsoft, and IIS. And this changed to CW20, HTTP server, and Apache in the recent time. At the network view, we can increase the link count filter to have a clearer view. It shows and confirms the relationships between CWE20, Apache, and HTTP server, and also show the relationship between CWE119, Microsoft, and IIS. Similar working pattern was used to analyze other use cases reported in our paper.